Referring to our LED chaser circuit diagram on your screens, we can see a low-frequency astable oscillator circuit made up of two gates, IC1A and IC1B from the IC4011 quad 2-input NAND gate. The operating frequency of this astable is determined by the values of C1 and R11. This circuit configuration works well as a clock pulse generator for feeding the IC1's 74 C164 shift register. The positive output pulses from the clock at pin 4 of IC2 are supplied into the shift register's clock input at pin 8 of IC1. Each output of the shift register is wired to an LED. Each LED is connected to a 1K current limiting resistor in series. The input of gate IC2C is connected to the 8th output of the shift register, located at pin 13, via a time delay RC configuration comprised of R10 and C3. The output of the gate is connected to the clear input of the shift register at pin 9 through a capacitor. LED 8 is turned on by the 8th clock pulse, and C3 is charged as soon as pin 13 of IC1 becomes positive. After a little delay, the output of IC2C becomes low, clearing the outputs of the shift register. The LEDs light up in the following sequence. LED 1 is turned on by the first clock pulse, LED 2 by the second, and so forth until all 8 LEDs are illuminated. The clear pulse from IC2C shuts off each LED once the 8th LED illuminates, and the process is then repeated. R10 and C3's values can be changed to make LED 8 stay on for the identical amount of time as the remaining LEDs. For a quicker sequence, the RC time delay circuit must be smaller, and for a slower series, it must be larger. Increasing the value of R10 or C3 will shorten the delay period, and decreasing the value will extend the delay time. If you have any doubts regrading the circuit, please do not hesitate to ask through your comments. Remember, I am always here to help you with your circuit projects whenever you need it, so you can absolutely feel free to comment and ask your questions here or in my website, homemadecircuits.com. All the best to you, and thanks for watching.